Hi guys, let's look at the next chapter. The next chapter that we do is complementary angles. This is the last chapter in the concept of trigonometry. So what are complementary angles? We've done this earlier. Complementary angles are two angles whose sum is 90 degree. Say for example, if angle x is equal to 40 degree and angle y is equal to 50 degree, and since angle x plus angle y is equal to 90 degree, therefore angle x and angle y are complementary. So that's the basic definition of complementary angles, which we've done since grade 6 or maybe grade 5. So let's look at how do we apply complementary angles in trigonometry. Now in a right angle triangle, which is what we're looking at in grade 9 and grade 10 for using our trigonometrical ratios, one angle is 90 degree. So the sum of the remaining two angles, yes, is 90 degree because the sum of three angles of a triangle is 180 degree. So for example, if this angle is 40 degree, this angle will obviously be 50 degree. So these two angles are complementary in a right angle triangle. So other than the 90 degree angle, the other two angles are right angle are complementary angle. Now if I call this as x, then this angle now becomes 90 degree minus x. Yes, so this is x and this is 90 degree minus x, and these two angles are complementary. Now let's look at certain ratios that we have. So let's look at sine x. So I'm looking at reference angle C. Let me just erase these numbers so that it's easier for you to understand when we without looking at actual numbers. Let's look at x and 90 minus x. So let's look at angle C as x and angle A as 90 minus x. So sine x would be equal to perpendicular, in this case AB, upon hypotenuse, which is AC. Let's look at cos x. Cos x would be base, which is BC, upon hypotenuse, which is AC. Tan x is perpendicular, which is AB, upon base, which is BC. Cot x is a reciprocal of tan, which means BC upon AB. And cosec x is reciprocal of sine, which means AC upon AB. And sec is reciprocal of cos, which means AC upon BC. So all this we've done with the reference angle x. Now let's look at a reference angle of 90 minus x, which means we're looking at sine, cos, and the other trigonometrical ratios for angle A. So sine 90 minus x, which means for this reference angle, my perpendicular is BC. So this is BC. Hypotenuse remains the same, which is AC. For cos, the base is AB and the hypotenuse is AC. For tan, perpendicular is BC and the base is AB. Cot is reciprocal of tan, so this is AB upon BC. Cosec is reciprocal of sine, which means AC upon BC. And sec is reciprocal of cos, which means AC upon AB. Now let's try and compare these ratios for reference angle x and reference angle 90 minus x. So if I look at sine x, which is AB upon AC, this is equal to cos 90 minus x. So these two are the same. So if I write sine x, I can also write this as equal to cos 90 minus x. Let's look at the next one, cos x. Now cos x, which is BC upon AC, is equal to sine 90 minus x. So cos x is equal to sine 90 minus x. Let's look at the next one, which is tan. So tan x is AB upon BC, and cot 90 minus x is also equal to AB upon BC, which means tan x can be written as cot 90 minus x. So there is a relation between the complementary angles. If x and 90 minus x are complementary, then sin x is equal to cos 90 minus x, cos x is equal to sin 90 minus x, and tan x is equal to cot 90 minus x. Let's see if we can get any other ratio or other relationship. Cot x is equal to BC upon AB. Similarly, tan 90 minus x is equal to BC upon AB. which means cot x is equal to tan 90 minus x. Let's look at the next one. Cosec x is AC upon AB, and sec 90 minus x is also AC upon AB, which means cosec x is equal to sec 90 minus x. And that brings me to the last one. The last one is sec x, which is AC upon BC, is equal to cosec 90 minus x, which means sec x is equal to cosec 90 minus x. So this is the new relationship that we figured out in a triangle where the remaining two angles are complementary. So sin x is equal to cos 90 minus x, cos x is equal to sin 90 minus x, tan x is equal to cot 90 minus x, cosec x is equal to sec 90 minus x, and sec x is equal to cosec 90 minus x, and the last one, cot x is equal to tan 90 minus x. Now this whole chapter will use these 6 relationships and we'll solve some questions. So let's look at the first question. The first question that we do is question number 1, part 1. It says evaluate cos 22 upon sin 68. So we will need to find a relationship between cos 22 and sin 68. I noticed that 22 and 68 are complementary, which is 60 plus 20, 80, and 88 plus 2, 90. So 22 and 68 are complementary, which means what I can write this as cos 90 degree minus 68 degree. So instead of 22, all I have written is 90 minus 68, and my denominator remains sin 68 degree. Let's check what I have done. Instead of 22, I have written it as 90 minus 68. So I know cos x is equal to sin 90 minus x, or cos 90 minus x is equal to sin x, which means I will write this as cos, sin 68 degree upon sin 68 degree. Reason, since cos 90 minus x is equal to sin x. So this is cos 90 minus x is equal to sin x. This is equal to 1. So please note, all I have done is written 22 in the form of 90 minus 68. Let's look at the next one. In this case, I change the numerator. In the second one, let's try and change the denominator. So this is sec 75 and cosec 15. Again, 75 and 15 are complementary because 75 plus 15 is 90. So this time I will change the denominator. So sec 75 degree upon cosec. Instead of 15 degree, I will write this as 90 degree minus 15 degree, because 90 degree minus 75 degree, not 15, 75, because 15 degree is nothing but 90 minus 75. So this can be written as sec 75 degree upon sec 75 degree. Reason for this, since cosec 90 degree minus x is equal to sec x, which is the same numerator and denominator, so the value is 1. Let's look at the next question. The next question that we do is question number 1, part 5. So sin square 40 degree minus cos square 50 degree. So let's convert cos into sin. Again, I notice 40 degree and 50 degree are complementary. So I leave sin as same. So sin square 40 degree minus, instead of 50 degree, I will write this as cos square 90 degree minus 40 degree, because 50 degree is nothing but 90 minus 40. So this becomes sin square 40 degree minus sin square 40 degree. Reason for this is since cos 90 degree minus x is equal to sin x. So this is sin square 40 minus sin square 40 is equal to 0. For our reference, I have already written these formula at the bottom, which is sin x is equal to cos 90 minus x, cos x is equal to sin 90 minus x, tan x is equal to cot 90 minus x, and the remaining relations are mentioned here. Let's look at the next question. The next question that we do is question number 1, part 7. It says sin 15 degree dot cos 15 degree minus cos 75 degree dot sin 75 degree. So Let's try and convert. So I notice that this can be converted into sine, because this would be can be cos, because sine 90 minus 75 will be equal to cos 75. Okay, so I can convert this into cos 75 and I can convert this into sine 75. Okay, so let's just write this in here. So this is sine 90 degree minus 75 degree, because 15 is nothing but 90 minus 75 dot cos, and here 15 degree again can be written as 90 degree minus 75 degree. Yes, 15 degree can be written as 90 minus 75, and the second term remains the same, which is cos 75 degree dot sine 75 degree. I don't change the second term, all I have changed is the 15 degree. I have written it as 90 minus 75. Now this is sine 90 minus theta, which is equal to cos theta. So this is cos 75 degree dot, this is cos 90 minus theta, which is sine theta, minus cos 75 degree dot sine 75 degree. Reason, there are two reasons, since sine 90 minus theta is equal to cos theta and cos 90 minus theta is equal to sine theta. So cos 75 dot sine 75 minus cos 75 dot sine 75 is equal to 0. Let's look at the next question. The next question is question number 2, part 1. It says evaluate sine 90 minus a dot sine a minus cos 90 minus a dot cos a. So sine 90 minus a can be written as cos a, and sine a we leave it like this, and this can be written as sine a. Alright, so this becomes cos a dot sine a minus sine a dot cos a. Reason, since sine 90 degree minus a is equal to cos a and cos 90 degree minus a is equal to sine a. So I have changed 90 minus a here and cos 90 minus a in the second term. So both these terms are exactly the same, which means my answer is 0. Let's look at the next question. The next question that we do is question number 2, part 3. It says cot 54 degree upon tan 36 degree plus tan 20 degree upon cot 70 degree. So let's change this in both of them into tan. So this becomes cot, let's write this in the form of 90 minus theta. So this is again 54 and 36 are complementary. So I can write this as cot 90 degree minus 36 degree, because 54 is 90 minus 36, upon tan 36 degree plus tan 20 degree upon cot 90 minus 20. Reason, 70 is nothing but 90 minus 20, and the third term is minus 2. So cot 90 minus theta is equal to tan theta. So this is tan 36 degree upon tan 36 degree plus tan 20 degree upon cot 90 minus theta is equal to tan theta. So this is tan 20 degree minus 2. Reason, since cot 90 minus theta is equal to tan theta, which means the first term is 1, second term is 1, third term is minus 2. This is 2 minus 2 is equal to 0. Let's look at the next question. The next question that we're doing is question number 2, part 5. It says cot squared 25 degree minus sine squared 65 degree minus tan squared 45 degree. So let's convert this into sine, because cos can be converted to sine, and 25 and 65 are complementary, which means I can write this as cos squared 90 degree minus 65 degree. So all I have done is converted 25 in the form 90 minus 65. The second term remains the same, minus sine square 65 degree, and I know tan 45 value is 1. So 1 square. So this is sine square 65 degree minus sine square 65 degree minus 1 square, which is 1. Now the reason for this, since cos 90 degree minus theta is equal to sine theta. So I have changed sine theta into, sorry, I've changed cos 90 minus theta into sine theta. So these two terms cancel out. This is sine square minus sine square, same angle. So this is equal to minus 1. These two terms cancel out and my answer is negative 1. Let's look at the last question for this video. This is question number 3, part 2. It says show that sine 42 degree into sec 48 degree plus cos 2 degree into cosec 48 degree is equal to 2. So let's convert sec into cosec, and let's convert cosec into sec. Yeah. And again I notice 42 and 48 are complementary. So the first term remains the same, which is sine 42 degree dot sec. Instead of 48 degree, I write this as 90 degree minus 42 degree. So all I have done is written 48 as 90 minus 42. In the second term, I leave cos 42 exactly the same and I change 48 degree as 90 degree minus 42 degree. So I am working with the left hand side. I have written nothing, changed nothing, but instead of 48, I have written as 90 minus 42. So the first term is sine 42 degree dot sec 90 minus theta is equal to cosec theta. In this case, cosec 42 degree plus cos 42 degree dot cosec 90 minus theta is equal to sec theta, which means sec 42 degree. Reason, since cosec 90 minus theta is equal to sec theta and sec 90 minus theta is equal to cosec theta. So these are the two things that I have put. Now cosec we know is the reciprocal of sine. So this is sine 42 degree dot multiplied with 1 upon sine 42 degree. Instead of cosec I have written sine, and this is cos 42 degree multiplied with 1 upon cos 42 degree. This gets cancelled, this gets cancelled. So what I am left with is 1 plus 1, which is equal to 2, which is equal to right hand side. Reason for this, since cosec theta is equal to 1 upon sine theta and sec theta is equal to 1 upon cos theta. So we've got left hand side is equal to right hand side, hence proved. Before I end the video, let me mark some homework questions for you. Homework question for you would be question number 1, part 2, 4, 6 and 8. In terms of question 2, you would do 2, 4 and 6, and question 3 you would solve question number part 1. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.